Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about preparation, properties, uses of PVC, Nylon 66 and Bakelite. So how can you prepare this PVC, polyvinyl chloride? This PVC is a thermoplastic polymer. PVC is the thermoplastic polymer. So thermoplastic means soft on heating, hard on cooling. Already we discussed previous sessions. So thermoplastic means soft on heating, hard on cooling, remolded polymer. So here PVC is a thermoplastic polymer and versatile polymer. And these polymers are generally formed by addition polymerization. So now let's discuss how can you prepare this polyvinyl chloride. So in this vinyl chloride, in this PVC polyvinyl chloride, vinyl chloride is the monomer. So the monomer used for the manufacture of PVC is vinyl chloride. Here PVC is the polymer. So in this polyvinyl chloride is the polymer. In this monomer is vinyl chloride. So this vinyl chloride monomer used for the manufacturing of polyvinyl chloride. So this vinyl chloride is prepared by treating with acetylene. Vinyl chloride is prepared by treating with acetylene with HCl at 60 to 80 degrees centigrade. First vinyl chloride, it is prepared by treated with acetylene with HCl is at 60 to 80 degrees centigrade in presence of metal oxide acts as a catalyst. In presence of catalyst. So then polyvinyl chloride is produced by heating vinyl chloride in presence of benzoyl peroxide or hydrogen peroxide. In presence of benzoyl peroxide or hydrogen peroxide. So this PVC is a thermoplastic polymer. It can be prepared by addition polymerization and it is a remolded versatile polymer. So here how can you prepare this PVC polyvinyl chloride? It is a polymer. So which monomer involved in this polyvinyl chloride? Vinyl chloride. So vinyl chloride monomer undergoes polymerization then form polyvinyl chloride. So which type of polymerization? Addition polymerization. So vinyl chloride undergoes polymerization then form polyvinyl chloride. So how to form this vinyl chloride? First, this is the acetylene. Acetylene reacts with HCl. Heating acetylene with treated with HCl. In the temperature range is 60 to 80 degrees centigrade in the presence of metal oxide. In the presence of metal oxide, then form vinyl chloride. Acetylene treated with HCl at 60 to 80 degrees centigrade temperature and here catalyst is metal oxide, then produces vinyl chloride. So then this vinyl chloride undergoes polymerization in the presence of hydrogen peroxide or benzoyl peroxide. This hydrogen peroxide or benzoyl peroxide acts as a catalyst. Generally, what purpose we are using catalyst? To speed up the reaction. So here, this vinyl chloride undergoes polymerization in the presence of hydrogen peroxide or benzoyl peroxide, then produces polyvinyl chloride. It is a polymer. But this vinyl chloride is a monomer. Here see this image, PVC plastic granules. So how can you prepare this one? It's polyvinyl chloride. It is prepared from the vinyl chloride. The vinyl chloride monomer undergoes polymerization in the presence of hydrogen peroxide or benzoyl peroxide, then gives polyvinyl chloride. So how can you prepare this vinyl chloride monomer? So acetylene treated with HCl at 60 to 80 degrees centigrade temperature in the presence of metal oxide acts as a catalyst, then gives vinyl chloride. Then this vinyl chloride undergoes polymerization, then gives PVC. It is a thermoplastic polymer. This is the preparation of polyvinyl chloride. Now let's discuss properties of PVC. Properties of polyvinyl chloride. So PVC is a lightweight. and durable and abrasion resistant material by nature. It is available lightweight, so easily we can transfer and easily we can use our domestic usage, industrial, etc. So PVC is a lightweight, durable and abrasion resistance material by nature. And second one is all inorganic chemicals have no effect on this flexible thermoplastic polymer. There is no effect of all the inorganic materials on this polymer. So all inorganic chemicals have no effect on this flexible thermoplastic polymer. And due to high electrical strength, high dielectric strength and vapor barrier capacity. So PVC is an excellent insulation material. It acts as a excellent electrical insulation material because of due to its a high dielectrical strength and vapor barrier capacity. So this is having high excellent insulation material and it resistance to adverse weather conditions, stress and corrosion also. And PVC material have inherent flame retardant property and it has high tensile strength and naturally stiff. High tensile strength means where it becomes very hard material. So it has high tensile strength and naturally stiff. So it is a cost effective option. It is available at less cost. It is a budget friendly. So it requires less maintenance and resistance to grease and oil. It requires very less maintenance and it resistance to grease and oil. So because the durability is higher, the product will last longer. Durability is more, so it will use long life. It gives long life. So because of high chlorine concentration, so PVC good self extinguish because of high chlorine concentration. So it can be made more flexible and softer by adding plasticizers. So what is the use of these plasticizers? To provide plasticity nature, flexibility. So for example, tricrysyl phosphate, triphenyl phosphate. So when we are adding these plasticizers for preparation of these plastics, it provides plasticity nature and flexibility. And it can be bent to meet the user's need. Easily we can mold, we can bend because it's having more flexibility. So these are the properties of polyvinyl chloride. It is lightweight. Simply we say, so what are the properties of polyvinyl chloride? It is lightweight, durable and abrasion resistance material by nature. So all inorganic chemicals have no effect on this polymer. And it is a thermoplastic polymer, so easily we can remold it because these plastics are soft on heating, hard on cooling. So during heating process, it becomes soft, so easily we can reshape, reused again and again also. And it has adverse weather conditions, stress and corrosion, and water resistance also. Cost effective. It has a high tensile strength, naturally stiff, and it has less maintenance and is resistant to grease and oil and provides longer life because of its high durability, and it has more chlorine concentration, so it is good self extinguish. So it can be more flexible and softer by adding plasticizers, so it can be bent to meet the user's need. So these are the properties of polyvinyl chloride. Uses of PVC. Uses of polyvinyl chloride. So here plasticized PVC is utilized in flooring while unplasticized PVC is used to make window frames. So plasticized PVC it is used in flooring and unplasticized PVC is used to make window frames. Here are given some of the examples which are made up by this PVC. PVC pipes used for construction and wiring purpose, insulation it gives, and packing materials also we can use this PVC, and automotive parts made up by this PVC, and toys also. In medical field also use this PVC. It is having most versatile properties and it is a thermoplastic material. So here plasticized PVC is utilized in flooring, and unplasticized PVC used in this making window frames. And next one is this PVC used to make sewage pipes. PVC is used to make sewage pipes and other pipe applications where the usage of metal is prohibitively expensive or vulnerable to corrosion. These are having high corrosion resistance. So this PVC is mainly used to make pipes, sewage pipes or different pipes. Other pipe applications also we are using this PVC material because they are having high corrosion resistance, and it is utilized in various industries. It is utilized in various industries including construction, electronics, electrical cables, automotive, medical, and packaging. So this PVC pipes or PVC is used in various industries, electronics, construction and electrical cables, automotive, medical and packaging. So various fields we are using this PVC materials, and also use it for making aprons, shower curtains, raincoats, jackets and sports bags, all made from this PVC fabric. This PVC polyvinyl chloride fabric also used for making aprons, shower caps, raincoats, jackets and sports bags, all made from this PVC fabric, and also used in the construction industry for electrical wire insulation, and also use this PVC in construction industry for electrical wire insulation or flooring in hospitals, schools, houses and other sectors where a hygienic atmosphere is necessary, because it is most preferable material and is easily you can remold it, easily you can use this material, and it is highly flexible material and available in budget friendly, and it is having high corrosion resistance. So what are the uses of PVC? Mainly it is used in this construction field, medical field, schools, buses and insulation purpose. Mainly we are using this PVC. Next second type is Teflon. It is also called as polytetrafluoroethylene. Polytetrafluoroethylene. Shortcut form is PTFE. Polytetrafluoroethylene. It is a polymer. So how can you prepare this Teflon? So it is obtained by polymerization of water emulsion of tetrafluoroethylene. Tetrafluoroethylene under pressure in presence of benzoyl peroxide acts as a catalyst. Here see, this is a Teflon tetrafluoroethylene. Tetrafluoroethylene, it is a monomer. So number of Teflon monomers undergoes polymerization. So what is the meaning of polymerization? Monomer undergoes polymerization, then form polymers or low molecular weight compound converted into high molecular weight compound. This process is called polymerization. Generally two types of polymerization: addition polymerization and condensation polymerization. Already we discussed previous class what is the meaning of addition polymerization and with examples also. So this PVC and Teflon, these two are formed by addition polymerization. So here Teflon, tetrafluoroethylene, number of tetrafluoroethylene monomers undergoes polymerization in the presence of hydrogen peroxide or benzoyl peroxide. These two are acts as a catalyst. So to speed up the reaction. So this tetrafluoroethylene undergoes polymerization, then gives polytetrafluoroethylene. Polytetrafluoroethylene. So in this polytetrafluoroethylene, here monomer is the tetrafluoroethylene. When number of tetrafluoroethylene monomers undergoes water emulsion of tetrafluoroethylene undergoes polymerization under pressure in presence of hydrogen peroxide or benzoyl peroxide, acts as a catalyst, then gives polytetrafluoroethylene. Here see the structure, it is clearly explained. So here number of tetrafluoroethylene. So number of tetrafluoroethylene undergoes polymerization. So this is the chemical structure of polytetrafluoroethylene. polytetrafluoroethylene. So then undergoes polymerization, then form this polytetrafluoroethylene. So this is a 3D structure of polytetrafluoroethylene. Here this grey color indicates carbon atom and green color indicates fluorine atoms. These are the fluorine atoms and this grey color indicates carbon atoms. So this is the preparation of Teflon. So how can you prepare this Teflon? It is obtained by polymerization of water emulsion of tetrafluoroethylene under pressure in presence of hydrogen peroxide or benzoyl peroxide, then form Teflon. So now let's discuss properties of Teflon. Properties of Teflon. So Teflon is the extremely tough, flexible. Teflon is the extremely tough, flexible material possessing high softening point. It's about 350 degrees centigrade. So this Teflon material is it is having high, tough, flexible material and it is having high softening point. It is a 350 degrees centigrade. And it possesses good electrical and mechanical properties. Good electrical and mechanical properties. And it is having chemically resistance towards all chemicals except hard alkali metal and hard fluorine. It is having high chemical resistance towards all the chemicals except hard alkali metal and hard fluorine. So remaining all, it is having high chemical resistance with remaining chemicals. And it has excellent thermal stability. It has excellent thermal stability. So it is having tough, flexible material and it is having high softening point. It is 350 degrees centigrade and it possesses extremely good electrical and mechanical properties and it has chemical resistance. It has chemical resistance with all chemicals except hot chlorinated or hot alkali metal and hot fluorine. And it has electrical excellent thermal stability, heat resistance. So what are the uses of Teflon? So already we know that Teflon is the synthetic fluoropolymer. Teflon is the synthetic fluoropolymer made up of polytetrafluoroethylene. Teflon is made up of tetrafluoroethylene. Just now we discussed already. Tetrafluoroethylene, water emulsion of this tetrafluoroethylene under pressure in the presence of hydrogen peroxide or benzoyl peroxide then gives polytetrafluoroethylene. It is also called as Teflon. So it is a synthetic fluoropolymer made up of tetrafluoroethylene. It has wide range of applications across various industrial due to its unique properties. Various industries applications we are using this type of most preferable materials in industries because of they are having more unique properties. So here I given some common uses of Teflons. So first one is non-stick cookware. Every houses we are using our domestic purposes nowadays. Most preferable is non-stick cookware because it takes less time and very tasty. So in this case, first application of this Teflon is the non-stick cookware. So this Teflon is most recognized as a non-stick coating for cookware such as baking sheets. Why you are preferring these non-stick pans or non-stick cooking purpose? Most preferable because its non-stick properties prevent food from sticking into the surface. So non-stick means it is prevent food from sticking to the surface and making it easier to cook and clean. It takes less time also. So this is the main advantage. That's why mostly in nowadays we are preferring this non-stick items, non-stick cookware, which are made up by this Teflon. And second application is industrial applications. Because of the unique properties, we have preferred this Teflon materials mostly in industries. So widely used in this industrial applications such as coating for bearing, gaskets, seals, valves and pipes to protect them for wear and tear, and reduce friction and enhance their performance. enhance their performance. And it is also used as a non-stick coating for conveyor belts and other equipment. That's why this material also most preferable in industries also. Domestically we are using this cookware, this Teflon coated cookware, and second one is industrial applications also, and third one is electrical applications. Electrical applications. So this Teflon is used in electrical applications as a coating for wires, cables, connectors to prevent them from short circuiting and protect them from moisture. This Teflon is used also for electrical applications also. This Teflon materials used in electrical applications. For what purpose we are using coating for wires, cables and connectors for prevent from short circulating and protect them from moisture, heat and chemicals. That's why we are using this Teflon coated materials in electrical applications also, because they are prevent from short circuiting and protect them from moisture, and it is also having heat resistance and chemicals resistance, and its high dielectrical strength. Having high dielectrical strength, it is also makes it an ideal insulator for electrical components. It has dielectric strength. It is also make it an ideal insulator for electrical components. So that's why I prefer mostly in non-stick cookware, industrial applications, electrical applications, and also some of the applications of Teflon is medical applications. So this Teflon is also used in these medical applications such as coating for medical devices, implants and prosthetic due to its biocompatibility with the human body. That's why this Teflon coated material is also used in industries or medical applications also, and its non-reactive nature and low friction coefficient also make it suitable for use in surgical instrument and equipment. Use in surgical instrument, it is suitable for surgical instrument and equipment. So that's why we are most preferred used in this medical applications also. And next one is automotive applications. So this Teflon is used in automotive applications as a coating for engine components. It is also used in automotive applications. It is mainly used for coating for engine components such as piston rings and bearing to reduce friction and wear, enhancing their performance and durability in this automotive industry. And next one is chemical processing. So Teflon is used in chemical processing industries as a coatings for tanks, pipes and other equipment. So that comes in contact with chemicals to protect them from corrosion and chemical damage. And last one is used in this Teflon coated materials in aerospace in applications also. So here Teflon is used in aerospace applications as coating for aircraft components. Coating for aircraft components such as fuel tanks, hydraulic systems and electrical connectors to prevent corrosion and improve their durability. So these are the main applications of Teflon. Mostly we are prepared for making non-stick cookware and also used in electrical applications and also used in industries we are preferred, and also used in medical applications and automotive industry, chemical processing and aerospace applications. Aircraft industry also we have preferred this Teflon coated materials. And third one is Bakelite. So Bakelite, it is also called as phenol formaldehyde resin. It is also called as phenol formaldehyde resin. So this Bakelite, it is a thermosetting polymer. It is a thermosetting polymer. But PVC and Teflon is the thermoplastic polymer. So those polymers easily made up by addition polymerization and remolded polymers. But here Bakelite is the thermosetting polymer and formed by the condensation polymerization. So what is the meaning condensation polymerization? It is formed by two different functional group of monomers and elimination of byproduct. It is a cross-linking polymers. That's why we are using here resins also. Resins are the basic binding material and it is a cross-linking polymer. So it forms cross-link with neighboring chemicals or neighboring atoms. So Bakelite or phenolic resin, or it is also called as phenol formaldehyde resin, it is a thermosetting polymer. We cannot remold this polymer. Only hard on heating. It becomes hard. We cannot reuse it again. So it is called thermosetting polymer and formed by the condensation polymerization. It is formed by the condensation polymerization. So how can you prepare this Bakelite or phenol formaldehyde resin? So it is obtained by the condensation polymerization. Just now we discussed this polymer, this Bakelite is prepared by the condensation polymerization of phenol and formaldehyde. This polymer is prepared by preparation of phenol and formaldehyde in the presence of acid or alkali catalyst. What is the catalyst we are using here? Acid or alkali catalyst. So here this phenol Bakelite is prepared by the condensation polymerization of phenol and formaldehyde, and here using catalyst is acid or alkali catalyst. So in this preparation, Bakelite preparation, it's involved total 3 steps. It's involved total 3 steps. So step 1 is, in the step 1, reaction between phenol and formaldehyde. Phenol and formaldehyde. Condensation polymerization of phenol and formaldehyde. That means condensation polymerization means it forms two different functional group of monomers. Two different functional group of monomers. So in this phenol, it present hydroxy functional group. It's present hydroxy functional group. In this formaldehyde, it present aldehyde function group. So phenol and formaldehyde in the presence of acid or alkali catalyst. So undergoes which type of polymerization? Condensation polymerization. So this phenol and formaldehyde undergoes condensation polymerization in the presence of acid or alkali catalyst. So in this case it gives orthohydroxy methylphenol, orthohydroxy methylphenol and parahydroxy methylphenols are formed. So in the step 1, the preparation of Bakelite. So what is the first step? The reaction between phenol and formaldehyde undergoes condensation polymerization, then gives orthohydroxy methylphenol, parahydroxy methylphenol. That means in this phenol structure, ortho position it is containing hydroxymethylphenol. Hydroxy group presented ortho position, here methyl hydroxy group presented para position. So phenol and formaldehyde undergoes condensation polymerization in the presence of acid or alkali catalyst. Then it gives orthohydroxymethylphenol and parahydroxymethylphenols are formed in the step 1 for the preparation of Bakelite. The next step 2, in the preparation of Bakelite, in the step 2 is in the orthohydroxymethylphenols. So these orthohydroxymethylphenols are heated with excess of phenols. Heated with excess of phenols in the presence of acid catalyst. In the presence of acid catalyst to form novolac. To form novolacs. So here is orthohydroxymethylphenol. Orthohydroxymethylphenol. This orthohydroxymethylphenol reacts with or heated with phenol. Heated with phenol in the presence of acid catalyst. In the presence of acid catalyst. So to form novolacs. To form novolac. Next, the step 3. For the heating of novolac resins in the presence of curing agent. For the heating of this novolac resins in the presence of curing agent. Here curing agent is the hexamethylene tetramine. Hexamethylene tetramine produce hard, rigid, insoluble cross-linked polymer is formed that is named as Bakelite. So this novolac product is heating with curing agent that is hexamethylene tetramine then produces Bakelite. It is a highly insoluble cross-linking hard polymer named as Bakelite. This is the structure of Bakelite. So here overall 3 steps which are involved in this preparation of Bakelite. So this is a step 1. So what is the step 1? Condensation polymerization of phenol reacts with formaldehyde in the presence of acidic or basic catalyst, alkali catalyst. When these two phenol and formaldehyde undergoes condensation polymerization, then gives orthohydroxymethylphenol and parahydroxymethylphenol. Next is in this step 2 is orthohydroxymethylphenol. Orthohydroxymethylphenol heating with phenols, treated with excess of phenols. So in this case it forms novolac. It forms novolac. Next is step 3. This novolac is treated with hexamethylene tetramine. It is a curing agent. It is heated with hexamethylene tetramine. So in this case it produces Bakelite. So Bakelite is a highly cross-linking polymer. Highly insoluble and cross-linking thermosetting polymer, and these polymers are prepared by the condensation polymerization. Here condensation polymerization means 2 different functional group of monomers and eliminating byproduct. So here water molecule is the byproduct. So it is formed by 2 different functional group of monomers means here phenol is having hydroxy function group and formaldehyde is having aldehyde function group. So 2 different function group of monomers undergoes polymerization, that means condensation polymerization, then form Bakelite. It is a thermosetting polymer. So this is the preparation of Bakelite. So what are the properties of Bakelite? So Bakelite is a thermosetting or thermoset plastic. Bakelite is a thermosetting plastic. That means only hard on heating. Once it convert hard material, we cannot soft again. We cannot reuse it. Very hard material formed during heating process. So we cannot reuse it again. The type of polymer is called thermosetting polymer. So Bakelite is a thermosetting plastic. So therefore, when heated, the polymer is malleable and liquefiable. So easily we can mold it. It is having cracking resistance. We can reshape it without breaking. It is called malleable and liquefiable. So however, when it is cold, it becomes permanently hard and resin material. Only during heating process only we can convert. So after that it is cool, it becomes permanently hard and resin material. We cannot reshape again during heating process because it is a thermosetting polymer, thermosetting plastic, and it is a non-conductor of electricity. It is a non-conductor of electricity. So it is having dielectrical constant of 4.4 to 5.4. It is having a dielectric constant of 4.4 to 5.4, and it is having high heat resistance. It is having heat resistance. So therefore, it is non-flammable. Thus, it functions as a good insulator. It is a good insulator, and it is also having resistance to any kind of chemical action. So hence it is non-destructive. Hence it is non-destructive. So it can be very easily and quickly molded during heating process. So the molding of bakelite are fairly scratch resistant, and usually it has brown or amber color. Usually brown color. However, it can be found in variety of colors nowadays in market. It is available in variety of colors. And bakelite has distinctive sticky, sweet, or fishy odor. So these are the properties of bakelite, mainly used in electrical. It acts as a good electrical insulator, and we cannot remold it after heating process. And it is having malleable and liquidable properties and high heat resistance. It acts as a good insulator. Easily we can mold it during heating process, and it is available in variety of colors and also used in this used as an adhesive. So used in paints. So now discuss uses of bakelite. So it acts as a good insulator. It acts as a good insulator. So therefore, it is widely used in making several electrical devices. So it acts as a good electrical insulator. So good insulator. So therefore, it is widely used in this making several electrical devices such as like sockets, automobiles, distribution caps, switches, insulation wires, etc. Some of the examples here are given, so which is made up by this plastic bakelite material. So it is acts as a good electrical insulator. So that's why we are using in this electrical industry for what purpose, like sockets, automobile, distribution caps, switches, insulation wires, etc. We are used in this electrical devices, this bakelite material. And it is also used for making non-conducting parts of radios, telephones. It is also used non-conducting parts of telephones, radios, and it can be very easily molded on heating process. Thus, it can be used for making variety of daily used commodity like clocks, toys, in this dominoes, cheese, chips, etc. we are using, and washing machine impellers also made up by this bakelite material. We also used buttons, kitchenware, etc. we are using this bakelite material for preparation purpose. And since bakelite is available in variety of colors, it is available in variety of colors. So it is also utilized for making artificial jewelry like bangles, earrings, bracelets, etc. It is available in variety of colors. So it is also utilized for making artificial jewelry like bangles, earrings, bracelets, etc. And it is widely used in adhesives or binding agents and as varnishes and protective coatings. In this case, it is used as a adhesive, and is also used in making musical instruments. Musical instruments like saxophone, whistle, and electrical guitar, etc. Which is also a musical instrument also made up by this bakelite material. So in this session, we learned about how can you prepare this PVC, Teflon, and Bakelite. So what are the properties and applications of this PVC, Bakelite, and Teflon? I hope understood all. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.